Next example, evaluate double integration over r e raised to minus x square dx dy, where r is the region bounded by the lines y is equal to 0, x is equal to 1, and y is equal to x. So y is equal to 0 means x axis, x is equal to 1. This is the line x is equal to 1, that is the parallel to y axis and at a distance 1 from origin. And y is equal to x is this line that is divides this first quadrant and third quadrant in two equal parts, or makes an angle 45 with x-axis and y-axis. This divides this plane, this quadrant in two equal parts. This y equal to x line, and this is the area bounded. This shaded portion is the area bounded by these three lines, and we have to integrate this e raised to minus x square over this region R. So double integration over R e raised to minus x square dx dy is equal to. Now we have to decide that we have to integrate it with respect to y first or with respect to x first. If we integrate e raised to minus x square y with respect to y first, then what is your advantage? That the e raised to minus x square becomes a constant with respect to y. So it is a requirement of the example that you have to integrate with respect to y first, because if you have to integrate with respect to x first, then e raised to minus x square integration becomes complicated. So we decide that we have to integrate with respect to y first or x first. It's depends on the example. In some examples, that is like these examples, in this example also this example, we integrate with respect to y first or with respect to x first. It doesn't matter. In both methods, we have the same answer, and both the methods are simply simple. But in some examples, with respect to x or with respect to y first, is depends on the example. That is, in some examples, with respect to y it's convenient, with respect to y first is convenient. In some example, with respect to x is convenient. And the answer of this 4.19 here is solved with respect to y first and then with respect to x. And the answer, we can also solve this integration with respect to x first, and we have the same answer. And the answer with respect to integrating with respect to x first is shared with you through WhatsApp group. So observe both the procedures. We have the same answer, 3 by 56. So in this example, we also integrate with respect to x or with respect to y first. Okay, we have the same answer. So, but in this example, we have to integrate with respect to y first. If we integrate it with respect to x first, then this become complicated, because e raised to minus x square integration with respect to x becomes complicated. So with respect to y first, we integrate. So we have to integrate with respect to y first. That means we have to take a strip parallel to y-axis. So draw here strip parallel to y-axis. Draw the strip parallel to y-axis, and then the limit is on y first, and then limit on this is on x. So what are the limits on y? So one end of that strip is touches to the line y is equal to 0, and therefore y is equal to 0 is its lower limit, and the another end of the line, the strip, touches to the line y is equal to x, and therefore y is equal to x is the upper limit. So we have the limit 0 to x on y, and in order to cover this region, we have to move the strip from this point to this point in order to cover this strip which is parallel to y-axis. So we move the strip from this point to this point, that is x runs from 0 to 1. X runs from 0 to 1. Okay. X runs from 0 to 1. Okay. And therefore the limit is on x is 0 to 1. And then e raised to minus x square with respect to y integration is e raised to minus x square into y. Integration with respect to y from 0 to x. Then substitute upper limit as y, value of y as x. We have this answer. And if we substitute y as 0, then value at lower limit is 0. So we have this. and its integration is by using substitution. Substitute x square is equal to t, and therefore twice x dx is dt. Therefore x dx is what? 1/2 dt, 1/2 dt. And as x tends to 0, if you substitute x as 0, then t is also 0. And if x tends to 1, that is, if you substitute x as 1, then t is also 1. Okay, so limits are same, that 0 to 1, e raised to minus t. X into dx is 1/2 dt. X into dx is 1/2 dt. And then e raised to minus t integration is what? E raised to this 1/2 is constant now. E raised to minus t integration is e raised to minus t divided by minus 1, and that's why it's minus 2. Then value at upper limit, that is e raised to minus 1 minus e raised to 0. E raised to minus 1 means 1 by e. E raised to 0 is 1. So we have this answer, e minus 1. E is LCM, so write e minus 1 by 2e. Okay, e is LCM. So what do we have? 1 minus e. So absorb the sign, e minus 1 by 2e. So in this example, integration with respect to y first is convenient. Sorry. Then next example is evaluate integration 0 to pi by 4 dx, integration 0 to sec x y cube dx. That is, first integrate y cube with respect to y. So it's y raised to 4 by 4, 0 to sec x. Substitute y as sec x, we have this. Substitute y 0, we have the answer 0. And then integration 0 to pi by 4 sec raised to 4 dx is what? Then in order to integrating sec raised to 4x, we adjust that, right? Sec square x into sec square x, and sec square x, and the another sec square x is 1 plus tan square x, because sec square theta is 1 plus tan square theta dx. And then substitute tan x as t, then sec square x dx as dt. So x is 0, then t is also 0, because tan 0 is 0. And if x is pi by 4, then tan pi by 4 is what? Is 1. Tan pi by 4 is 1. That is, x tends to pi by 4. If x is pi by 4, then t is 1, because x is pi by 4, then tan pi by 4 is 1. So the limit are what? 0 to 1, 0 to 1, 1 by 4, this 1 by 4, 0 to 1. And sec square dx is dt, and 1 plus t square, tan x is t square, 1 plus t square dt. And then its integration with respect to t is what? T cube by 3, 0 to 1, upper value at the upper limit, that is substitute t as 1, we have this answer. If we substitute t as 0, we have 0. So we have the 1 by 3 answer. Okay. Next problem, double integration over d, and d is the rectangle bounded by this 0 to 1. X runs from 0 to 1, y runs from 0 to 1. Okay. So we can draw the figure out directly, right? Double integration of x square divided by 1 plus y square dx dy is integration 0 to 1, integration 0 to 1. X and y runs from this x square into 1 by 1 plus y square dy. Then integrating with respect to y first, or integrating with respect to x first. So here is the integration with respect to y, means x square is constant, and the integration of 1 by 1 plus y square is tan inverse y, 0 to 1. And then value at the upper limit, tan inverse 1 minus tan inverse 0 dx. Tan inverse 1 is pi by 4, and tan inverse 0 is 0. So we have here pi by 4, take that pi by 4 as constant out of the limit. And integration of x square is x cube by 3, 0 to 1, 1 by 3 into pi by 4, it's pi by 12 is the final answer. Then here the integration 0 to 1, 0 to 1 of this integration integrand, that is x minus y divided by x plus y cube dy dx. And then the integration of with respect to x first of the same function with respect to x first. These two are different. Why these two are different? Because this function is not continuous. When this order of, we can change the order of integration. So observe the Fibonacci theorem. What is the theorem? If the limit are constants, here is the limit are constants, then the limit of x on x and y are constant, then change the order of integration, there is no change in the function, or there is no change in the limit. That is c to d is the limit on y, and a to b is the limit on x, fxy dx dy. So change the order dy dx, just change, replace the, or interchange the integration sign. But when, if fxy is continuous throughout the rectangular region, if this function is fxy is not continuous, then these two may or may not be set. So in this example, if fxy is continuous, then we can change the order of integration very easily if the limits are constants. Okay, and if the limits are not constant, then in order to change the order, we can use the strip parallel to x-axis or y-axis. We know that if the limits of x or even limit of y, these are the limit on y. These are, so the order is what? The order of integration is this bracket means integrate with respect to y first, because the limit of y is in terms of variable, and then integrate with respect to x. Or if the limit of x is in terms of variable, then integrate with respect to x first. So here is if the limits are constant, then we can integrate it with respect to x first, or we can integrate with respect to y first. But when, if the function is continuous throughout that rectangular region. So here the two values are not equal. We have to show these two values are not equal, means this function is not continuous over that rectangular. That's why we have the different answer. Otherwise we have the same answer. If the function is continuous over that rectangular, this function x minus y divided by x plus y cube, this function is not continuous in this rectangular region, that 0 to 1, 0 to 1. And that's why we have the different answer if we change the order. That is, we have to solve this LHS by integrating with respect to y first, and we have to find the value of RHS by integrating with respect to x first. But the limits are constant, but the answers are different. Why? Because this function is not continuous over that rectangular. Okay, so we have to solve this example. Now we will find the value of LHS separately and RHS separately. So consider LHS and is equal to, the adjustment is what? This x minus y arranged in this way, 2x minus x in bracket minus x plus y. If you simplify this, 2x minus x means x, and minus y, we have the same answer. So 2x minus x, and then separately divided by x plus y cube to separate divide. So 2x divided by x plus y cube, x plus y divided by x plus y cube is 1 by x plus y square. And then integration with respect to y. So 2x is constant quantity, and 1 by x plus y cube means x plus y raised to minus 3, and x plus y raised to minus 3 integration is what? X plus y raised to minus 3 plus 1 divided by minus 3 plus 1. That is x raised to minus x plus y raised to minus 2 divided by minus 2. That is minus 1 by 2x plus y square. Okay, minus 1 by 2x. 2x is constant, and the integration of 1 by x plus y cube is what? Minus 1 by 2x plus y square. And the integration of 1 by x plus y bracket square is again with respect to y integration, means x is constant, and this factor is of the type ax plus b, and therefore it is x plus y raised to minus 2, its simplification. And then integration is x plus y raised to minus 2 plus 1 divided by minus 2 plus 1. That is x plus y raised to minus 1 divided by minus 1, minus 1 become plus 1, and x plus y raised to minus 1 means 1 by x plus y, or the derivative of 1 by x is minus 1 by x square. So y runs from 0 to 1 dx, and then value at the upper limit, substitute y as 1. Its simplification is this, its simplification, x plus y square is the LCM, 2 get cancelled, y minus x is the numerator. Then value at the upper limit, that is substitute y as 1, we have this answer, and substitute y as 0. If we substitute y as 0, then we have if we substitute y as 1, then 1 minus x divided by x plus y, x plus 1 square, and then substitute y 0, we have the answer minus x divided by x square, that is minus 1 by x, minus 1 by x. So the calculation is this: 1 by x plus 1 bracket square, 1 by x plus 1 bracket square. If we substitute here, if we substitute y as 1, and we have the answer, and minus y as 0, 0 to 1. So we have this answer, 1 by x plus 1 square. Actually, we have the answer. If we substitute y as 1, then we have answer minus x divided by x plus 1 bracket square. And if we substitute y as 0, then we have minus x divided by x square, that is 1 by x minus 1 by x minus plus 1 by x, and then take LCM as x plus x into x plus 1 square, and then we have this answer. So value at the upper limit minus value at the lower limit, and its calculation is this. And then its integration is what? Minus 1 by 1 plus x. So x plus 1, this is x plus 1 raised to minus 2. And its integration is what? X raised to minus 2 plus 1 divided by minus 2 plus 1. That is x raised to minus 1 divided by minus 1. That is minus 1 by 1 plus x. And then the value at upper limit is minus half. The value at lower limit, that is substitute x at 0. Minus minus plus 1. So we have the answer 1 half. So this is the answer of LHS. Similarly, consider RHS. This. And then adjustment is like this. But what? Right, this x minus y is x plus y minus 2y. If we simplify this, then we have the answer x plus y minus 2y. Y minus 2y is minus y. So we have the same answer. And then separately divide by x plus y cube, x plus y bracket cube. We have this. Then integration of this factor is 1 by minus 1 by x plus y. Again, 1 by x plus y square means x plus y raised to minus 2. Its integration is x plus y raised to minus 2 plus 1 divided by minus 2 plus 1. And here is the x plus y raised to minus 3, means 2y is constant. 2y as it is, 2y as it is, and x raised to x plus y raised to minus 3, integration is x plus y raised to minus 3 plus 1 divided by minus 3 plus 1, that is minus 2 plus minus 2 by minus 2. And minus minus become plus, here plus. So we have this. X turns from 0 to 1, then find value of this bracket. This bracket calculation is what? X plus y as a LCM. We have this, and then value at the upper limit, that is substitute x as a x as 1, and then x as 0, and after calculating we have this, and its integration is 1 by 1 plus y, because again 1 plus y raised to minus 2, its integration is y 1 plus y raised to minus 2 plus 1 means minus 1 by minus 1. So it is become this, and then value at the upper limit. Though we have the minus 1 half answer. So the LHS answer is 1 half, the RHS answer is minus 1 half, and these two are not equal. So the if the limits are constant and if the function is not continuous on that region, then we may have the different answer if we change the order. So same type of examples we will discuss in the next lecture.